need to expose a simple calculation to your AI without worrying about complex return type definitions or manual output formatting. We'll create a basic addition tool that demonstrates FastMCP's automatic primitive handling, where integer results get wrapped in a structured result field according to the 2025 MCP specification. You'll see exactly how the framework generates both content and structured content outputs, even when you omit explicit return annotations.
At MCP, tool. Def calculate sum A, int B, int. Calculate sum without return annotation. Return a plus B hash returns 8.
This demonstrates the AI tool protocol pattern, where Python functions become standardized endpoints for language model interaction through declarative metadata. The @MCP tool Decorator implements the 2025 MCP specifications tool protocol, automatically generating both invocation schemas and output structures from native Python type hints. The distinctive aspect is how it bridges Python's type system with AI expectations while maintaining complete separation between your implementation and the protocol layer. The pattern operates by treating function signatures as the single source of truth for tool definition. Type annotations determine the input schema and return structure, while docstrings provide human-readable descriptions that become part of the tool metadata. When executed, FastMCP automatically wraps primitive return values in a standardized result value structure within the structured content field of the MCP response, ensuring compatibility with the specification while preserving your function's natural return behavior. This dual-layer output, combining both human-readable content and machine-processable structured data, happens transparently without requiring manual serialization. This approach eliminates the traditional friction of AI system integration by handling protocol compliance at the framework level. You write normal Python functions with standard type hints, while FastMCP manages the entire MCP protocol layer, including schema generation, input validation, and output formatting. The automatic primitive wrapping and structured output generation make it particularly effective for building AI agents that need both human-interpretable results and machine-readable data, all while maintaining clean separation between your business logic and the AI interaction layer. Let's break it down line by line.
At MCP, tool. Def calculate sum A, int B, int. Calculate sum without return annotation.
The @MCP tool Decorator exposes this function to AI models under the 2025 MCP specification. FastMCP auto-generates the tool schema from type hints and docstrings, while handling serialization and validation, even without explicit return annotations. Primitive returns like this int get automatically wrapped in a result key within the structured content field, ensuring consistent output format across all MCP tools.
Return a plus B hash returns 8.
This returns the sum of A and B as a primitive integer, which FastMCP automatically wraps in a result value structure in the output schema per MCP 2025 specification. The tool generates both content, human-readable and structured content, machine-readable fields in the response, maintaining consistency across all primitive return types without requiring explicit annotations. FastMCP output schema generation. The @MCP tool Decorator automatically creates structured output schemas from Python type hints, with primitive returns wrapped in a result key to comply with the 2025 MCP specification. Omitting return annotations still generates a schema defaulting to result primitive, wrapping for all basic types. Every tool response includes both human-readable content and machine-validated structured content fields.
The schema that describes nothing becomes the foundation for everything.